Now that we've introduced CFD, we're now ready to look at a demonstration. So I'm going to take you through a demonstration workflow of how you can use CFD in your day-to-day design. Today I'm going to be focusing on a car, and I'm going to be looking primarily at the air intake and the flow throughout the cabin. Currently I'm in Autodesk Inventor Professional, and I'm looking at my 3D model that I've created in here. So you can see all my parts, my step-by-step guide within my model assembly, so you can see all these. And now what I'm going to do is send this across to CFD. So this is great for designers because they can actually bring their simulation earlier on in the project, saving money and making design changes earlier on in the project to save it downstream, costing a lot more money. It also is a lot simpler to use, so you don't have to be a CFD expert in order to understand the CFD environment and its intuitiveness. I'm now going to go to my Autodesk Simulation CFD tab, and here you can see I can launch the model. So I can either launch the model, launch an iParts assembly, or launch CAD entity groups. So the launch iPad and iAssemblies means that you can do multiple versions. So if you have set up iParts or iAssemblies within your model, you can load this. Today I'm going to launch the active model, as I only want to focus on this one particular model. So what it's going to do now, it's now going to prompt the model to open up CFD, and I'm going to call this CAD Fair, and I'm now going to launch it. And this is now going to take me into the Simulation CFD environment and load the model. As you can see, this has now been imported. It instantly brings up some geometry tools. So this would be useful if I was trying to add a void, for instance, on an LED light, and I wanted the ceiling void, and I wanted to add that. I could create myself a specifically sized void. But for today's demonstration, I don't need this. So I'm going to close that down. As you can see, if I zoom in, I've got this model. It's taken away all of the colours, and it's brought in a standard unassigned model. As you can see, it's familiar looking. You've got your view cube in the top right hand corner, as you have with Inventor and AutoCAD, and it works exactly the same way. You can actually change the controls so they're exactly the same as Inventor, but personally I like to keep them the same just so I know I'm in a different package. You also see the familiar setup, so the ribbon feature in the top, where you've got your typical left to right workflow. You've got your results, view, and your getting started, so helpful tips. You can also see in my design study bar, I've got my materials that have come across. So if I hover over them and go through and select different types, you can see they're coming up on the screen. So these have been unassigned. They've come through with no actual entities or information assigned to them yet because they need to be mapped accordingly with the CFD materials. So first of all, what I'm going to do is I'm going to select my materials tab, and I'm going to start and go about setting this up and assigning materials to all of the relevant parts. So if I select on it here, it has a kind of a traffic light system, so you know when you're selecting it. If I edit here, I can now set this up as I'm going to use the default materials, select a solid, and I'm going to create this as steel. I'm going to hit apply, and you can see this has been added in the bottom left hand corner. I'm now going to get rid of that, and I'm going to select this part. So I'm going to set this as my volume part, edit this, and I want this to actually be air. So if I go to fluid, select air, and apply that, you can see it's changed the colour again. And I'm going to get rid of that just so I know that I've assigned these materials. You'll also notice in the top left, these are all being assigned and put into the relevant categories. I'm going to now go around and select all of the wheel components, and I'm going to change these. I'm going to change these as a solid, and I'm going to change these to silicone rubber and apply these. And I can now get rid of these. Now I know they're in the environment, so I'm just hiding them at the moment. I'm not actually getting rid of them or changing them in any way. And now I'm going to add the interior. So if I put the interior like so, again, edit the type, and I'm going to change this to a solid, and I'm going to put this as a graphite, carbon. And before I change it, I'm actually going to go into the materials editor and I'm just going to change the colour. I can see the colour, it's pretty similar to my silicone rubber, and I want it to look a little bit like the interior, so we go for more of a yellowy beige colour. I'm going to hit OK and apply that like so. So that's now added that in there. I can now get rid of that. And I'm just going to rotate my model slightly. I'm going to select these and assign these properties. I'm just going to put this as fluid air and apply that. Again, now I've done it, I can get rid of it just so I know I've completed it. And if I just highlight the remaining parts, these are all now glass, so you can see they're highlighted in the window. Right click, edit it, change to a solid, and I'm going to save that as glass and apply that. Now if I right click and show all, it's going to bring back all of the components within the assembly. Move that down just so I can see that. And now you can see all of the components within the assembly. I'm now ready to move on to the next stage because everything's been assigned, everything's correct, and I'm now ready to look at my boundary conditions. So I'm going to begin by selecting my boundary conditions tab, so continuing the left to right workflow. I'm going to right click and select surfaces. I'm going to get rid of, actually before that I'm going to try a volume. Let's hide this. And we can hide these. Because at the moment we just want to focus on the internal parts. So I want to set my boundaries up for the interior so that I can work out where the air is flowing and make sure it's in the correct position. I'm going to hide those as well. So I don't want the glass units. As you can see, it's very simple to do. Okay, so now I've hidden that, I'm just going to check that I've got the front screen as well, which I have, which is perfect. So now I can go about setting up and adding the air intakes into the part. So if I just go to surface, I'm going to add some information into this surface here. So if I right click again and edit, I want to select this as temperature, and I want to keep everything as standard, but I want to put it as 20 degrees. So that's going to be coming in through the air conditioning from the engine itself. I also want to add that part as well. You can see it's been put into the bottom left. But I also want to add a mass flow rate. And for this, I'm going to add 100. So this is the speed at which it's going to be flowing through. And as you can see, I've added two little lines, which was basically just showing that this is the case. Before I go any further, I'm just going to change it to an outline, and I'm going to select these parts. So if I just edit these parts, so that's actually going the wrong way. So that's the correct way. I can apply it through there. And we can edit that. Just make sure it's going in the right direction. I can now go back and I'm going to have a look at the back. So I need to find an air intake that, well, the air intakes at the back, so this air can flow through the car itself. I'm going to go back to here. Change the view back to shaded so I can now see it. Select that surface. On both sides. I'm going to edit that. As you can see, we've got our pressure, and again I want to reverse normal, just because I want this to act as almost the end of the airflow, so it's just pushing it back in. And I'm going to apply that. So that's now added a pressure onto the back. So I've got a mass flow and a pressure on 2 boundary conditions. So just go back and double check to make sure that's there, and you can see the line's been added onto both of them. Just deselect all, so that's now been added in. One final thing on my boundary conditions, I want to select all, so if I just drag a line around, I'm going to edit this and I'm going to add a film coefficient. So let's go through here and add it onto the part, and I'm just going to put the coefficient as 5 and the reference temperature as 37 degrees. So if I apply that, you'll notice it's added film the whole way around. So this is like a worst case scenario. So the outside heat could possibly be up to 37 degrees, and I want to see how it's cooled throughout the interior of the project. Once I've done this, I've set up all my boundary conditions. I'm now ready to move on to the next part. Now that we've created our materials and we've established our boundary conditions ready for the CFD simulation, we can now go to the mesh settings suitable for this component. So I'm going to select the mesh settings. So meshing is how fine and how well the simulation can actually be created. So first of all, I'm just going to have a look at it and decide which parts are going to be simulated. So I'm going to hide this part. I'm just going to focus on here and look at the actual body. So I'm going to select, I can have a right click here and auto size the mesh, or I can select it on the top. So I'm just going to select it here. So what it's going to do is it's going to compute the mesh for me now on this selected area, and it's going to see what needs to be defined. As you can see in the bottom in the output bar, you can see it's computing, it's checking, and it's working its way through. So if I bring up the edit bar, you can see here the approximate value very high. So I can either get rid of some areas or just select certain parts. So I'm actually going to go back now and I'm going to suppress certain parts. So I don't need all of the components to be visible. So if I bring that back. The reason for this is when you do a simulation, if you're using too many points within here, so if you too many elements, it's going to take a long time and it needs a lot of computing power. So I'm going to exclude this now. I'm going to suppress that. And I don't need to simulate the wheels, they're of no real interest to me, so I can suppress the rubber parts. I quite like the parts, but I don't need any of the windows, so I can suppress that again. And I'm going to leave those parts now. So now if I go back to meshing, I go to auto size, we can just check to see if there's going to be any difference in size. So there you can see the approximate count has come down dramatically. So that's great. So this means my simulation is going to be a lot quicker and I don't need that part because it's roughly 2 gigabytes of RAM for every million elements. So 6 for this is fine, 6, 7, and I've got enough in this PC that it will be covered for it. So I can also hide this part. Let's have a little look. And I can select this duct area, and I can actually move this across. So I could probably make it a bit coarser, a bit less coarser, sorry. So I could put this at 0.6. I think that's fair enough. And I can apply that. I can now bring out the air, so let's pull this back. And let's highlight here. And we can go back and we can show all. Again, I can get rid of this for a second. Still in our mesh. You can see here, I'm just going to hide this part. And I could actually select this part and go into edit and say, well, actually it doesn't really need to be that coarse. So I could turn it a little bit coarser because it's not going to make too much of a difference. And I could apply it to that element. Once I've done this, I'm now ready to hit the solve button and create my part. So I've done all my prep work, I've imported it, I've set my materials, my boundary conditions, and I've now defined my mesh, and I can now hit the solve button ready for the simulation. Now this will take about 5 to 10 minutes, and I'll be back with you once this has been completed. So first of all, just forgot to tell you there that I was going to go through, before we simulate it, I'm going to simulate this, and I'm going to put continues from 0, I'm going to set 100 iterations, and now I'm going to hit solve. You can see we've now completed the analysis successfully. As you can see, it's gone through all of the list of requirements, so it's gone through and calculated different parts and all the inputs that we've added to it, such as the air, the glass, the carbon and the rubber. Now what we're going to do is I'm going to take you through a series of how we can export some results from this, because it's all very well creating a simulation, but what are we going to do with it now, and how are we going to make it relevant to what we need it to be. So I'm going to take you through a series of parts and just pull that out. First of all, we're going to look at the convergence plot. So as you can see, it's a nice little graph that shows you how all the different velocities, the temperature, the scalar, the TED and the pressure, and this is all built up. So you can select these individually and go through. So this can either be done down here, or we can go up to our results settings at the very top. So for instance, if I want to look at temperature. So here you can see it's automatically brought up the temperature details. So I've got my temperature Celsius from 20 to 36 degrees. So that's the difference in cabin pressure between there. So first of all, we can select parts. And what I'm going to do is I'm just going to select the air volume at the top. So I'm just going to tick that. Just make sure that's up to date. So I calculate that. So here we can see we've got a series of results very quickly from the cabin. So I could have picked the airflow going through the vents, but as I click the cabin, so here we've got volume 19, the complete volume area, I've got the average temperature of 24, the max temperature of 26, and the minimum temperature of 20. So that's throughout the cabin, and you can see that as well through the colours. So if I was just to close that down, I could have saved that and add that into my decision centre later on, but I'm not going to for the time being. So if I pull out my options, I can change the level, so the colour options, if I wanted to put it into black and white or a thermal. Depends on how I want to show it and how I best see this, how best see it fit to show. I'm just going to leave mine at normal. I can also select a user specified range, so if I wanted to concentrate on say 20 to 40 degrees, then I could set that if I thought that was deemed the best way for my results. So we've now gone through that, we're now ready, so we can now look at how the heat's actually transferred throughout the cabin itself. So in order to do that, I'm going to select a plane. So if I select a plane and I select the add button, if I just turn this to the side, you can see that's instantly taken a plane down the centre for me. I can move that, I can use the little grab handles here to move it up or down or left or right, but I'm quite happy with that, so I'm going to leave that in its position. I'm just going to go back and change the visual side at the moment, so I've got a transparent. I quite like it, it gives me a good visual so I can see the actual air around the plane itself. So I now want to see whether it's met our kind of goal of uniform cooling. So these airs, so as you can see, it comes in, if it's hot in the cabin, I want the airflow to come through and evenly distribute, so to keep it to a decent and comfortable temperature. So first of all, I'm going to plot a graph. So by doing this, I just want to plot a few areas and see the change in temperature throughout that zone. At any point I can use the shift key just to pick up the dimension and also pick up the temperature for that particular part. So now I'm just going to select by the footwell several parts Put another one there. Another one there. Let's just go up a little bit further. And now if I select plot, what this will do is this has actually plotted my parts. So you can see where I was a little bit irregular there. So I started at the top and I went back and did a few. You can see where it's followed that chart. But you can see, so from the vent, it's slowly getting cooler. So when I'm up to, like, say, the average person's head height, it's now a comfortable position and you're in a comfortable zone. So the temperature's being distributed and cooled effectively as we would want it to. Once you've done this, you can save this data. So you can save an image, you can save the points, again, so you can come back to it when you come back to your decision center. But I would probably just save this and save it as an image and then move on to the next part, so it now will be stored in my results part. Now that we've traced the area and we've put some points in, so we've established where they are on the X and Y plot, we now know the temperature going up from the bottom to the top, so the vertical temperature change. Now what we need to do is we want to change this plane around, so I'm going to change the view slightly, and I'm going to use the control features on this plane to take a flat view. So let's put that like that, and let's make sure I put it on the Y plane, like so. So you can now see this is taking a cut through the middle, so we can now concentrate on, like, the airflow coming through the vents, how it's going to be moved throughout the cabin. So in order to do this, temperature is not the best way to do it, because we want to work out how it's flowing. So we can now use the velocity magnitude, so we can actually see. So if I zoom in slightly there, you can see almost what looks like spray coming out of the vents. It's also added a velocity magnitude legend on the left, so we can see exactly how it's come out. I'm going to lower that so we can get a better view of the product itself. So I can actually go through and hit control and point different parts on this to get different temperatures and view that. And I can also add different planes to see the different temperatures. So it's good just to show, and we can do exactly the same as we did before and plot a graph. What I really want to do now is I want to actually test through the vents and work out how this is going to come through, what's the flow going to be like, and how the air is going to be dissipated through the actual cabin. So in order to do this, I'm going to select traces. I'm going to go down, I'm going to select this vent at the beginning, and I want to add trace lines to it. So if I zoom in, add some lines, but instead of picking the plane, I actually wanted to do a rectangular grid, so I wanted to actually assume like it's air coming through. So if I select a rectangular grid, I've selected this face, and I'm going to zoom in a little bit, and I'm going to start adding my points. So if I zoom across, you'll notice I'm pulling some points across now, and I'm going to drag it down, so I've got an airflow coming in through that area. Once I've done that, I can then add this trace set list. If I just move it out of the way and zoom out slightly so you can get a better appreciation of how this is working, you can see as we've set up, it's now beginning to kind of explain why we set up these boundaries at the very beginning. So you can see here now we've got all of the trace lines, so it's coming in, we've got different points coming out of the ventilation, so it's coming through, going through the cabin, so you can see here it's going between the two chairs and then coming into the back. What is apparent as well, so let's leave that and continue. If we now look at it, we can change different views, so I can just put an outline. You can now see the heat coming through and the temperature and how it's being pushed around, so it's coming down and it's a little bit warmer as we looked at the footwell when we put the trace points in earlier. So you can see that kind of change in temperature, And you can notice from here at the back, so if we go into our legends, I could focus this up a little bit so we can just see. You can see now it's getting warmer towards the back of the car. So the back of the cabin is where the heat's kind of coming through. So this could be, in order to do this, perhaps we could add some additional vents behind the seats just in order to keep the passengers in the back a bit more comfortable. And again, we can go down and we can change some of the colours. So we can change the thermal colours how you want to view it, just for your viewing ease. But we'll leave it as standard at the moment. But this way it just shows the actual car coming through, how it's created. Now that we've looked at the velocity magnitude and also the temperature within the planes, we can now move on to the next part. So the next part I'm going to look at isosurfaces. So if I select isosurfaces, what you'll notice with isosurfaces is that they represent a constant value. So i.e. Such as a pressure or a temperature. The best way to describe it is by showing you, but today we're going to look at the temperature. So if I select the isosurfaces, and I'm just going to bring the view back to here, I'm going to select the surface like so. So here you can see it's instantly taken that picture. We're looking at about 30 degrees as on the legend itself. So we're now going to have a look at it. So if I right click and edit, what I'm going to do is I'm going to bring up the control surfaces. So if I bring it to the left, as you can see, it's going to bring up the minimum. So sliding it to the left shows the lower temperatures. As I start building it up, it's going to show me where the higher temperatures are. So as you can see from here, as I mentioned earlier, it's starting to heat up around the back. So you've got this high-end temperature at the very back of your cabin. So this could be an issue. It might be useful to kind of add some more, or add the flow, increase the velocity. So we can now go back and have a look at the vector settings here. So again, I can pull that down. I've got exactly the same controls. I can change the appearance. So if I just wanted to add an outline, so you can see it more as a topography. But I'm going to leave it on shaded at the moment. So I could actually change the results here, so I can see the length. And this is just different ways of showing it. And to give you a decent view of how it's going to work. Go back to my controls and I'm just going to put magnitude on again. And let's have a look at this. So you can see it's only a tiny bit, and it's just showing you how that's going to work. So you can see how the air is coming out, where it's going. So obviously where it flows down the bottom, where I've still got my trace lines on, it actually means that it's hitting the seat and it's getting pushed down, so it's actually getting positioned in this way. So this is great just for showing visually how it's going to work and how you can see it. So if we were to look at 250, so you can manually put these in and input these, and we can go in again and start pulling that across, just to show how the velocity and how the surface is going to be, and how the difference in temperature throughout the cabin is going to be.